colored pens up. Of course, pencils may not be used for this phase. Colored pens only. Today's warm-up is a review of the last chapter, or at least some of the concepts. Pretty much straight solving equations. So let's see how we're doing with this concept. Number one, what did you get? We'll start with Cameron, Natalie, and then Tristan.
18.
Yes. T is equal to 18. Very good. Number two, what did we get? We'll start with Stephen, Catalina, and then Annabelle.
Q equals 23.17.
Okay?
23.17. 23 and 17.
Q is 23.17 or 1700ths, however you want to say it. Number three. We'll start with Alexis, and then Angela, and then DeAndre. What'd you get, Alexis?
G equals 1.9.
Okay.
G equals 1 and 9/10.
Very good. G is 1 9/10 or 1.9. Number four, what did you get? We'll start with George, Savannah, and then we'll go to Nolly.
0.30.
Okay.
0.42.
Okay.
0.22.
W equals 0.42. Number five, what did we get? We'll start with Kiara, and then we'll go back to Cameron, and then Tatiana.
-7.
-7.
-7.
N is -7. Number six, we'll start with Cameron M, George, and then Chelsea.
140.
Okay?
104.
C equals 104. Number seven, what did you get? We'll start with Amani, Angela, and then Essence. Okay?
-3.
Okay? Negative, I just couldn't hear you. You trailed off a little bit. -102. Okay, so we have a bit of a disagreement. And?
192.
Okay, we got three different answers floating around. David?
-192.
X is -192. And number eight, what did you get? We'll start with Savannah, then back to Tatiana, and then back to Alexis.
-54.3.
-540.
So we have a slight disagreement, but two people agree that it is -54.3. So let's talk about number seven because, well, I'm sorry, let me back up for a moment. We had 8 questions, so make a fraction out of 8. This is a very high-level math class. I believe strongly that you should have gotten all of these correct in the ideal world. But making a mistake here or there is not a big deal. So 6 out of 8 or 7 out of 8 would be decent enough. So figure out your percent for yourself. Give me a thumbs up if you got 75% or higher. Good, put your thumbs down. So that was most of us. Give me a thumbs up if you got 88% or higher. Good, put your thumbs down. That was more than half the students. So now, today's lesson, the new lesson, is going to build on what you already have learned. So knowing how to do these 8 questions is critical to being successful today. So I would like to talk about number 7 for a moment. Because there were some people who got it right and some people who got it wrong. So we know that in my class, to solve an equation, we always start by drawing our t. That's going to be critical today. But then you have to know what to do. So what do you do to solve a question that looks like that? Or an equation that looks like that? Cameron?
You
Multiply. Good. Could someone elaborate and be more specific? Angela?
Multiply both sides by -3.
You said that perfectly. Multiply both sides by -8. 5 words. Multiply both sides by whatever number is here. So this will cancel this because one's on top and one's on the bottom, and that's how we get our x. And then you have to multiply 24 times -8, and that's where we get the -192. Comments, questions on number 7? Oh, yes, Annie?
No.
You sure? Okay. So this is going to come up again today. Are there questions on any of the other ones? Cameron? Number 4, Natalie? Number 4. I'm guessing you got 0.33. So what happened was that my students knew what to do, but they don't know how to add properly. So you added 0.1, added 0.1, but you put the 0.1 in the wrong place. So just to make it a little bit bigger, this is what you really had trouble with. Two and 0 is 2, 3 and 1 is 4, 0. Okay? Comments, questions?
On number 2, the reason why I got it wrong is because I didn't see the decimal.
Okay, and I had a number of people on number 8 who also seemed to miss the decimal point, so that's okay. I can deal with that. Any other comments or questions? Okay, there was no. Today we make a big leap forward, an important leap forward, from the concept of solving a one-step equation to the idea of solving a two-step equation. It doesn't sound that dramatic, but in actuality it's an important leap. Before I get into it, I'd like to direct your attention to my whiteboard over here. I'd like you to look at a question that I was working on with one of the Algebra 1 honors students this morning. So looking at it right now, some of you might be able to understand some of it, but for most of you it's probably like looking at a foreign language. It should look pretty complex to you. So this is the work that the Algebra 1 honors students are doing, and so 1 year from today, you also will be working on something just like this. So we have to somehow teach you and develop the skills necessary to work on something as complicated as this. Not only that, you're not even seeing what they had to really do. This first equation here, the students wrote themselves. That's not from the book. They had to write this themselves, then they had to rewrite it following some rules so that it became this equation. And in fact, this first equation and this last equation are exactly the same thing. They just look different. And so this is something you're going to have to be able to do a year from now. So how do we get there? Well, you already started. Knowing how to solve a one-step equation is the key. Some of you kept balking. Some of you kept saying to yourselves, well, Mr. Gallup's telling me to make a table and then write it like this, but I can do it mentally, so I don't need to do that. And then I kept standing next to you saying, well, don't do that. You're going to see why really soon. Just trust me, I know what I'm doing. Some of you still continue to do that, and those of you who continue to do that are going to struggle a little more than the rest of us. Because knowing those basic skills is critical for today. So today we're going to learn how to solve two-step equations. The goal is exactly the same as it was before. The goal has not changed. The goal for solving an equation is the same no matter what. Isolate the variable on one side. Once you have the variable isolated, then you've got the solution on the other. So what is the difference between a one-step and a two-step? Well, here are two examples of two-step equations. So you should have these down on your paper. Leave some space underneath and on either side of them. And the process has not changed at all. We start the same exact way we always have. And since I have two examples up here, we're going to work on them simultaneously so you can see that it's the same no matter what it looks like. So, the first step is always the same. We're going to draw our t. And we're going to draw our t. As I explained when you learned this a month or so ago, this is an organizational tool. It's a training wheels technique, but it's a really important one. Now we're going to solve the equations. But before we solve this, I'm going to change it. So I'm going to do some whiting out. You don't white out. I just want you to look up here. So I don't know how to solve this. That's what you're saying in your brain. I don't know how to solve this, but now I'm going to change it. So what if that was the equation? How would you solve that? I should see tons of hands up, lots of confidence, lots of comfort. Adriana, how do I solve that?
Do the opposite of the
Okay, well, I didn't use the word opposite. I used a different word, but it's the same basic idea. Tristan? Inverse. Okay, so could someone be really specific? What am I going to do to this equation to solve it? Savannah?
You can do the inverse operation for you get for 12.
Okay, so guys, we haven't quite gotten good enough at speaking on how to do this. So let me see. 5 words. I'm looking for 5 words. Amani? Subtract 12 from both sides. So that is the simplest way. 5 words. So to solve that equation, that's what we were taught to do. Okay? But now, let me back up because this is not the equation. It's a little different. There's this. But we know that subtracting 12's something. Now let me white out something different. What if I whited out that? How would I solve that equation? Stephen?
You do divide both sides.
5 words. Divide both sides by -8. So this would be divide by -8. Divide both sides by -8. So we know that there's a dividing by -8 involved. And as we covered a minute ago, we know that there's a -12 on both sides. The question becomes, which do we do first? So that's your new lesson today. You already know exactly what to do. You just have to learn what to do first. So before we do that, let me talk about the purpose of solving an equation. The purpose of solving an equation is to find a missing piece of information. That's what you're trying to do. Find something that's missing. So I'm going to use myself and my keys as the concrete example of this. Okay? So if I'm walking down the street, we're going to pretend that this is a sidewalk or a street or whatever. And I'm walking and I just keep walking, I'm listening to my music or something, and I'm walking, and I get all the way over here, and my keys. Where are my keys? Oh man. I can't find my keys. So, now trying to kind of insert yourself in Mr. Gow's brain, what should I do now to try and figure out, solve this problem? What should I do, Fancy? Retrace my steps. Now, we tend to not actually walk backwards. We tend to turn around, but we literally tend to walk back on the same path that we took. to try and see if we can find our keys. That's the most logical thing to do. Where you first think to yourself, wait, where did I go today? Or what did I do? But if you're walking home from school or from work or whatever, yeah, I would literally walk back, looking for my keys, following the path back, oh, there they are. Okay. I retraced my steps and I found what was missing. So, when you are solving an equation, you are looking for lost keys. You're looking for the missing piece of information. This is important to understand because this is what determines what to do first. Okay? At the beginning of the year, we learned, or actually kind of mastered, order of operations. Please excuse my dear Aunt Sally is the little phrase we use to remember. We're not going to worry about parentheses and exponents right now. Let's just worry about my dear Aunt Sally. My dear is multiplication and division. Aunt Sally is addition and subtraction. So you learned when you have a bunch of operations to do, that's the order to do them in. But that's not what we're doing now. Now we're going in reverse. Now we're trying to find the missing piece. And so now we have to do things in the reverse order. So, when solving an equation, let me back up for a second. When simplifying something, like at the beginning of the year, we learned to do multiplication or division first, and then addition or subtraction after that. You always do multiplication or division first. But now we're looking for the missing keys. And so now we have to go in reverse. Which means that what was second comes first, and what was first goes second. So now, this is what we're doing over here. Addition or subtraction must be dealt with first, and then multiplication or division comes second. So this becomes our guide for what we're doing. So now, keeping that in mind, looking back at the equation on the left, what should I address first? Three light bulbs have gone off. 5 light bulbs have gone off. Catalina, what should I address first?
Subtract 12 to both sides.
Yeah. Since I am being now told to deal with addition or subtraction first, here is addition. So I have to deal with that first. So the first step will be subtract 12 from both sides. And then we work down. What about the equation on the right? What should be the first action that we take? Just 2 people can handle that now? No more light bulbs are going off? Nolly? Add 45 to both sides. That's right. Because again, we must deal with addition or subtraction first, and here we see subtraction. So that has to be dealt with first. And then of course we work down. Does anyone have any questions on why we go in reverse and what reverse means? George?
Well, the reason why we're going reverse is because usually when we're doing a regular one-step equation, you usually don't drop anything, you just keep walking on it and what you say, and we just go straight to the answer. But since we have 2 parts, since you dropped your keys, now you have to go, do the first step, and like, oh snap, I forgot it, and you go back.
Well, sort of. Actually, when we solved one-step equations, we were also going in reverse. That's why we do inverse operations. But the difference was there was only one operation, so you didn't have to worry about order. Now you do have to worry about order. Here's when you walk forward, because George is trying to understand and relate my analogy from the walking and the losing the keys. Here's when you walk forward. If I give you this, 18 divided by 3 plus 9 minus 2. That's when you walk forward. That's when you use the order of operations and you do multiplication or division, whichever comes first from left to right, and then addition or subtraction, whichever comes first from left to right. Okay? So this would be done first, because please excuse my dear Aunt Sally says you do multiplication or division before anything else. That's walking forwards. This is walking backwards. This is walking backwards. Because in both cases, we're trying to find something that's missing. When you're trying to find something missing, that's when you go backwards. The difference between these two is that you only have one step here. So you don't really have to think about it too much. You just have to know what to do. Here, you have two things to get rid of. You have to get rid of the 2, and you have to get rid of the minus 18. And so you have to know the order. Okay? Just like if I wrote this down, 62 minus 2. Do you have to think about what to do? You just 62 minus 2, right? You don't have to think about it. But here, you have to think about it because you have to know the order of operations. Here, you don't have to think about it because there's only one thing to do. Here, you have to think. But no matter what, you're building on what you already know. Okay? Are there any comments or questions? So these are not done in any way, but I'm stopping here because my only purpose on this screen is to show you the order and get us started. Now we're going to go through some formal examples. So example 1. So of course, the first thing we do is draw our T. And keep in mind that I'm skipping over a lot of the thought process that we learned. We learned when we first were learning how to solve equations, we talked about, okay, which side should we be looking at? What exactly should we be looking at? Now I expect that you've mastered that. And so now I'm skipping straight to, okay, what do we do first? So that's where we're at. Okay, so 4x plus 3 equals 19. What do we do first? We'll start with Amani, then Annabelle, and then Adriana. Amani, what are we going to do first? Okay, do you agree? Okay, one more time.
Minus 3 on both sides. Yes.
Yeah, we are starting with addition or subtraction, and so we have to start by getting rid of that. So we will subtract 3 from both sides. We do our little elementary school line, and now we work down. Remember that you're working down in columns. So here is the first column. 4x and nothing is 4x. Here is the second column. Plus 3 minus 3 cancels out. The third column is the equal sign. So we have equals. And then the fourth column is 19 minus 3. What do we get when we do 19 minus 3? David?
16.
You get 16. Very good. So now, let me move the 4x over. Now we're at 4x equals 16. So that was step 1 of the two-step equation. What's the next step? What do we do now? Natalie? Divide both sides. Divide both sides by 4. Divide both sides by 4. And now the 4 on the top cancels the 4 on the bottom, and we're left with our x equals, and now we just have to do 16 divided by 4, which you can all do mentally, is 4. And so now we have successfully solved a two-step equation. Comments or questions on any of that? Okay, part B. We of course draw our T. But there's something a little bit different about part B when you compare it to part A. And so we're going to talk about how we can make it a little more comfortable. I find, personally, this format to be very comfortable because we're going to get very used to this format. But now things are not in the right place. For example, the variable is over here. I want it over here. So what can we do to accomplish that? What can we do? Nala? Okay, what rule or what property says we're allowed to do that? Very good, excellent job. The commutative property says that when these two things are being added, which they are, yes, I know that's a subtraction sign, but we know that that's really just adding a negative number, we can move these things around, and that's the commutative property. And so, we're going to rewrite the equation so that it's negative 3c plus 9 equals 3. And now we can proceed much more comfortably in solving. What's the first step we're going to take? What's the first action? Cameron? Very good. Subtract 9 on both sides. Subtract 9. And again, we're working down in columns. Negative 3c and nothing is negative 3c. 9 and negative 9 cancels each other out. And 3 minus 9, what do we get from that? 3 minus 9. DeAndre?
Negative 6.
Very good. That's not 6, that's negative 6. So that's one step, and now we've got the second step. What's the second step going to be? Tatiana?
Negative 3 divided by, negative 6 divided by
Good, but what are my 5 words? Go ahead, Tatiana.
divide 3c by each side.
Close. You kind of butchered it a little bit, but I know you know what you're trying to say. Adriana?
Divide negative 3 from each side.
That's close. Divide both sides by negative 3. I know you guys know what you're saying, but you're misusing a couple of words. But yeah, we divide both sides by negative 3. The top negative 3 will cancel the bottom one, and we're left with c equals, and now negative 6 divided by negative 3, what do we get there? George?
2.
Negative 2? You
No,
sure?
2.
2. We get 2. And so again, we have solved the equation. Comments or questions on how this is done? Tristan?
Do we have to cross it out?
What do you think?
I don't cross it out.
Here's the rule. If you get the questions right every single time and you never get anything wrong, you can do whatever you want. Okay, we'll see. All right, so now the whole point is to be able to apply these ideas to a real-world scenario. You do not have to copy the question, but everyone needs to take 30 seconds and read the questions themselves after writing letter C, of course. Since the first week of school, I've been guiding you on an outline, a list of things that we're supposed to look for when trying to solve a real-world scenario. Could someone help us put together that outline again, or start us off? What's the first thing I always ask you to find? Start with Catalina, then Kiara, then Annie. Catalina, give me the first thing. Total always comes first, so everyone write down the word total. What's the next piece of information I always ask you to find, Kiara? There's a word missing from that. Annie's going to fill it in.
Flat.
Yeah, flat fee or a flat number. It really means a number that doesn't change. It's usually the start. Okay, there's another piece of information we are always looking for. What is the other important piece of information? DeAndre?
Rate.
Rate, very good. And the last piece, Tatiana? What's missing? So you need to be able to write this outline. The total should always come first. You can flip-flop, flat fee, and rate, it's okay. But total should come first. That should be the first thing you look for every time. So now we need to read through the question, and you need to pick out these pieces of information. Everybody, right now, I want you to lightly write down which number you think goes where. There's 3 numbers, there's 4 places. I want you to take a moment and see if you can figure out where they go. If you do it on your own, write it lightly because you might have to erase it. Okay, so what'd you put for total? What'd you put for total? Steven, what'd you put for total? Okay, what'd you put, Annabelle?
Oh.
You put 145 as well. Give me a thumbs up if you put 145 for the total. We got 1, 2, 3, 4 people. Okay. So then, what did you put? Somebody else. Nancy? 433. Okay, what'd you put, Amani? Okay, give me a thumbs up if you put 433 as the total. Okay, a lot of people put 433. Okay, in this case, it was confusing, but 433 is the total. And here's another word, even though I use the word total, here's another word that I'm thinking when I'm thinking the word total. I'm thinking the word end. What number represents the end of the scenario? And so when you think of that, you think of the situation, Marcus wants to have $433 at the end. So I understand why people chose 145 because it says his total amount of money is $145. But when I say total, I mean the total at the end. So what'd you put for flat fee? So that's probably going to change some of your answers. What'd you put for flat fee? Essence? 36. What'd you put, Catalina? 145. Okay. Well, give me a thumbs up if you put 36 as the flat fee. Okay. Give me a thumbs up if you put 145. Because those are the only 2 numbers left. Okay. Put your thumbs down. The flat fee is 145. For those of you who are struggling with that, another word for flat fee that I'm thinking of is start. What number was at the beginning? And in this case, Marcus has $145 to start with. So what is the rate? What is the rate? There's only one number left, Savannah. What's the rate?
36.
36. But even though it's the only number left, there is another reason. What's the reason that that's the rate? There's something that gives it away. Go ahead, Savannah.
Oh, because it says he earns a week.
A week. Very good. That tells you that that's a rate. So what's missing from the situation? What's the missing piece? Natalie? You said that perfectly. The number of weeks. And we can represent that with W. You can represent it with anything. X, N, W, whatever you want. But W is good in this situation. And so now we put it all together. What's the piece that I always tell you to start writing down when you're trying to construct the equation? Okay? Yeah. I always tell you to put the total down all the way to the right and put the equal sign. So now someone fill in the left. What's going to go on the left? Chelsea?
36W plus 145.
Very good. 36W plus 145. The rate and the variable will often, not always, but often will go together.
How do you know what they've done?
You'll learn later on in the year and some next year. For most of this year, it's going to go together. It's a good question, though. So now, normally we would solve the equation. We would continue on, draw our t, solve the equation. In the interest of time, I'm going to stop this question here because we already demonstrated that we now know how to solve equations doing these two. This question we were learning how to translate into an equation. Okay? Any questions on example 1? All right, let's see how you do on your own. Checkpoint number 1. You got one question, you got 2 minutes. You do not have to copy the original question, but you do have to follow the instructions. Follow the instructions. Number. Twice is very simple. All right, colored pens up. What's the equation that we're looking for? Equation only. We got 1, 2, 3, 4, 5 confident people, 6 confident people. We'll start with Cameron, Natalie, Catalina, David, George. Cameron, what was your equation?
2n minus 16 equals 36.
Okay, what'd you have, Natalie?
2x minus 16 equals 36.
So basically the same thing, different letter. What'd you have, Catalina?
2n minus 16 equals 36.
Okay, so 2n minus 16 equals 36. David, was that the equation you had? Okay, George? Okay, so George, what was the solution to the equation?
I got 26.
26. Can I have someone corroborate that answer? Chelsea, DeAndre, Savannah, what'd you get?
26.
Everybody thinks it's 26. It's because it's 26. Comments, questions, and concerns. Fancy and then Ann.
Can you do problem?
Yep. So let's talk about how this was constructed. How did I teach you to be successful with something that looks like this? I taught you something very specific. Does anyone remember what I taught you to do? It's okay if you don't remember, but hopefully after this you will remember. Stephen?
It's like the word like say like is, it means equal, and like the difference means subtract.
Okay, so first of all, you should have known what the words meant. But there was also a technique I taught so that you could successfully put it all together the right way. Nobody remembers? It's okay.
You said put the sign, like,
Okay, I did. I also said to work backwards. Because a lot of people get confused if you start from the beginning to the end. And I said start at the end and work your way backwards. So I always said start with the 36. Then the word is, as Stephen said, means equals. Then there's a number 16. So I know there's going to be a number 16 somewhere in here. And a number. So I know there's going to be a variable somewhere in here. And it says the difference of twice a number. So twice a number. How do I write twice a number? Angela? Times 2. So here's twice a number. Now keep going backwards. The difference of twice a number. The difference of twice a number and 16. So Stephen was right. You had to know what that word meant. You had to know what that word meant. You had to know what twice meant. You had to know what a number meant. But you also had to know the order that things went in. So does that make a little more sense now that you see kind of talked through?
yes, but like I understand like the problem, like how you worked it out. Not that problem, like
The solving the equation?
yes.
Okay, so let's solve the equation. Draw your T. Oop. What do you do first? Okay, I'm sorry, put your hands down. Give me a thumbs up if you got the correct solution. Thumbs up if you got the correct solution. Okay, Adriana, what do you do first?
First, I added 16 to both sides.
Add 16 to both sides because as we learned, we have to take care of addition and subtraction first. So you add 16, this disappears, and you're left with the 2n equals, and now we have 36 plus 16. What do we get when we do that, Nali? 36 plus 16.
52.
Very good, 52. What's the next step? Angela? Divide both sides by 2. She said it perfectly. Divide both sides by 2. This cancels out. The top and the bottom cancel each other out. And you're left with n equals 52 divided by 2 is 26. So where was the mistake, Nancy?
Oh, like I understand how you did it. I just want to make sure.
Okay, that's fine. Good. George?
Just wondering, I just noticed that if we never had a right to end, we could have gotten the same answer.
How so?
Oh, I was thinking about subtraction when I saw 16. I thought I saw 16 in mine, it was 26.
Okay, I'm a little confused, but that's fine. Essence? And then Annie? Okay, Annie?
Since I saw the difference of, I thought it was division, so that I did n and the division sign and then 2 plus 16.
Okay, so you understood everything except you misinterpreted a word. Does anyone remember what word means division? Or one of the key ones? Alexis? Quotient. So you actually have to know the words. Difference means subtraction, quotient means division. Okay? So it's okay. It's part of the learning process. Essence.
I skimmed the grade and I missed the word difference, so I put instead of subtraction.
Very good, and that actually happened in my last class as well, is some students kind of just glazed over the word difference and just immediately assumed it was an addition problem. That's okay, but now you see it, right? Very good. So now let's build on what we've done and look at some different ones. So don't start because I know some of you are really motivated and advanced and ready to go. I just want you to hold off for 1 second. So part A looks a little confusing, but I did my warm-up in a way that was done very purposefully. And we even went over one question on the warm-up, and I did that on purpose as well. So I want you to look at part A, and now I'm going to white out part of it and change the question for a moment. If this was the question, if that was the equation we had to solve, what would we do to solve it? If that was the equation to solve, what would we do to solve it? I know Cameron knows because he's the one who pointed it out during the warm-up. What was it? Multiply both sides by 5. So we multiply by 5, we multiply by 5. So guess what? We're going to do that again. The difference is that we have to know the order. So let me put back this. So we're going to get ourselves set up. We draw our T. And so what are we going to do first? What are we going to do first? Very good. Subtract 1 from both sides and work our way down. Here's the quotient of x and 5. That doesn't get added to anything, so it's just x over 5. Equals, because this cancels out, now we just have 9 minus 1, and 9 minus 1 is 8. Now if we go back to what Cameron had taught us, what are we going to do at this point? What are we going to do now? Amani? Multiply both sides times 5. Remember, this 5 is being written on top. It's being written on top because the top cancels the bottom. That's why it's written up there. And then we're left with the x equals, and now 8 times 5, we all can do that mentally, is 40. Excuse me. 40. So it's a matter of knowing the rules, knowing the order, knowing what you're supposed to do. Anyone have any comments or questions on how we did that? So let's go to part B, where it went from comfortable to a little bit uncomfortable. So we have something that we talked about a little while ago, but then we have something new we have to talk about. It is not in the order that I am comfortable with. First of all, the variable's on the right side and the number's on the left, but that's okay. I can deal with that. But I prefer this to be over here. I want this whole thing to be over here. So we already talked about that. What rule says that we're allowed to do that? Oh, we have a community answer, a commutative property. Very good. So we can rewrite the question so that it is 47 equals, now here's the key. The negative sign must travel with the fraction. So this is negative n over 15 plus 56. Does anyone have any questions on how we move those things around? Any questions on how we would go ahead?
Will it ever be like, let's say, if you switch it around, will it ever be like negative n over 15 times 56? If it's like that?
Further in the future, but not right now. Yeah, much further, way in the future. Yes, Tristan.
You see how you add, you put the negative n there, right? Then you have to put the negative sign behind it because when you multiply it, you get a negative number.
Okay, here's what I'm going to ask you to do. Wait till we finish the question and see if you still have the same question about it. Okay? So just hold off. So now we have it set up in a much more comfortable way. Now we're ready to solve. So now we're going to go ahead and draw our T. So what's the first thing we should do to try and solve this? Good, we got a lot of people. We'll start with David.
Wait, did you just call me David?
Wait,
We'll start with David.
You can put it near. I'm sorry.
Okay, I'll move on to someone else. Essence, go ahead.
First, we subtract 56 from both sides.
Very good. So we'll subtract 56 from both sides. Excellent. Because we have to take care of addition or subtraction first. This cancels out. Now we have to know our way of adding and subtracting and multiplying, dividing integers. What's 47 minus 56? What do we get from that? Kiara? We get negative 9. So here's what we end up with. Negative 9 equals negative n over 15. But here's the thing about negative fractions, and this is something you need to internalize now and forever in the future. A negative fraction does not mean the top and the bottom are negative. It means either the top or the bottom is negative. So this subtraction sign can either go here or it can go here, but it's not both of them. So the best practice in my class is to bring it down with the number, because the next step is to do what Cameron taught us, which is to multiply both sides, and we want the bottom to have the sign so that the top is just positive. And so now we can multiply the top and the bottom by negative 15. This will cancel this, and we're left with our n equals, and now we just have to do negative 15 times negative 9. No calculators needed for that. Yes, David. 135. Very good. Does anyone have any questions on this negative sign or anything that we did? Savannah?
Could you change the whole entire thing around?
Yes, it's called the symmetric property of equality. You can take the entire... You can use the symmetric property of equality and change the whole thing so that the whole right side can go to the left and the whole left side can go to the right.
Okay.
But you have to switch everything,
Yeah.
okay? And I like to do that myself. I usually immediately switch them.
Because it looks like a lot more complicated than...
It seems like it is. You're right. Okay, so now applying the same idea with something that we were exploring a little while ago is taking a statement that's written in English and translating it into math. So now we need to translate. So I taught you to start at the end. Well, it's easy to start at the end. You start with the 15. So we've got 15. What does the word is tell us? What does that tell us? Tatiana? Equals. Now work your way backwards. Okay, I have an 8. A number and 8. Well, it seems like it might be addition, so let me keep going. The quotient of a number and 8. So this whole thing, this whole phrase goes all together. The quotient of a number and 8 means n over 8. And then 11 minus the quotient. So 11 minus the quotient. So again, normally we would then solve the equation, but my goal here was just to help you see that this is the whole point. To be able to translate from English to math, and then to be able to solve it to find a solution. Does anyone have any questions on how we translated this? Okay. You had a question? Checkpoint number 2. Let's see how you do on this one. You got 2 minutes. All right. So what did we get? What's the solution to this equation? What's the solution? A lot of confidence. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we got a whole bunch of people. We'll start with Annie. We'll go to Tristan. We'll go to Steven. And then Natalie.
60?
60 with a question mark? 60? Okay. 60, okay. I skipped somebody. Who did I skip? I lost my number. Steven, go ahead. So far we have the same three answers. 60, the correct solution is 60. Are there comments, questions on this one? Kathleen? Well, what did you get? You got 180. Okay? So let's take a look at what you did. No, leave just like that. Okay. Any comments or questions? Okay, now I'm going to do something that I haven't done before. You actually have another checkpoint. Checkpoint number 3, putting everything together. You, of course, do not have to copy the question, but you have to solve and find the answer. So, you've got 2 minutes for this. Well, we'll bump it up to 3 minutes and see how you do. You got 3 minutes. Figure out something on your own. I'll be back to check on these. Tough to figure out. It's tough to figure out this question. So read the last sentence. That will help. All right, so how many prints? Got Cameron, Chelsea, Angela, and then Nolly. Cameron.
52.
52. Okay.
52.
Okay.
52.
Okay.
52.
Everybody thinks it's 52?
Oh, wait.
It's 52.
Excuse me.
So, so the equation that I used was this. And so I would have been glad to help as many people as I could, but as I walk around, I don't see anyone trying to do the outline that I taught you to do. So, or at least a few people did. So you should have started by writing total and then rate, flat fee, and then missing. So what was the total in the question? What was the total, Kiara? 15.83. That was clearly the total. The problem came with the rate. So what's the rate in this question? What's the rate, Cameron?
5.95.
Unfortunately, it is not the rate. But it seems like the rate. And so I don't blame Cameron and many others getting confused. Because it says per month. So that sounds like a rate. And guess what? It is a rate. But then something changed it. What changed it from the rate to the flat fee? Something in the question changed it. Chelsea? But I didn't get to that yet. I'm saying, what changed this from the rate to the flat fee? There was something that happened after it that changed it. Catalina? Well, that's what Chelsea was saying, is that's the rate, but you could have two rates. Why is this no longer a rate? Savannah?
Because it says the prescription cost. Yeah, the subscription.
The subscription cost, but it says per month. So that is a rate. You pay it each month. So it is a rate, but then something changed, and now it's not a rate anymore. Tatiana?
Because it said extra how many prints instead of
Okay, so that's part of it, is it says how many prints, but then there's something else that changed it. Kiara?
4 by 6 inch prints are 19 cents each.
Okay, so if you see that it says how many prints, and then it says the prints are 19 cents each, that tells you that we need that rate. But then how do we know that the $5.95 is now a flat fee? You guys are right, this is the rate. But how do we know that the $5.95 is now a flat fee? What makes it a flat fee? Angela?
It says for November.
It says for November. For November only. How many times do you pay the $5.95 within the month of November? Once. So you only pay it once, it becomes a flat fee. And the missing piece was the number of pictures, and then you put it together. That was not easy in any way, but definitely possible by this group of students. Okay? What I don't like is my students reading it, it wasn't obvious, and then you just stopped. Why did you stop? You shouldn't have stopped, you should have explored further. Okay? Yes, Molly.
For some reason, when I read the problem, I really got confuzzled. So I didn't know what was happening. So I basically just did a whole other thing, but I still got the answer.
Okay, well, I'll take a look at what you did, and maybe you did something right, maybe you got lucky, I don't know. Savannah?
I got the equation right, but I didn't get the answer right. I got 5.2 instead of 52.
Well, you made a mistake with the decimal place somewhere. So that might have been something you punched in your calculator. Because you say 5.2 and the answer is 52, that to me tells me just a decimal place mistake. Yes, George?
Never mind.
Okay. So everyone, draw a line across your paper. Your classwork is on page 122 in the textbook. You're going to do numbers 3 through 7. Number 7 has 3 parts to it. You have to answer each part separately. up your colored pens. Here are the first 4. And number 7 had 3 parts. First part, you were supposed to fill in the missing words for the question marks. So the first question mark was supposed to be the cost for the parts. And in our classroom, we call that the flat fee. So if you put flat fee, that's the same thing. And then number of hours of labor, that's the missing piece. Number 2, that's the equation, although in my class I would have had the 168 on the right and the 45h plus 78 on the left. And then part 3, when you solve that equation, you get 2 hours. All right, I apologize for the lack of time. If you have any questions on any of these, I'll be more than happy to help you during care class. But for now, I have to wrap up. Draw a line across your paper. Your homework is in the textbook. You're going to do on page 123, you're doing numbers 8 through 19 all. Not evens, not odds, all of them. That's 12 questions. And you are going to have a quiz on Thursday. And I am going to be starting with you a series of quizzes on what I will call basics. And these are concepts you were supposed to have digested and mastered from the beginning of the year. For example, on the basics quizzes can be divisibility rules, can be integer rules, and it could be order of operations. Any of those ideas can be on the basics